So another type of quadrilateral. We talked about trapezoids. We've talked about parallelograms. We've talked about kites. We've talked about rectangles. Here comes the next one, which is rhombi. Rhombus. Plural of rhombus is rhombi or rhombuses. And the thing is, when we're dealing with a rhombus, we also have to look at the parallelogram features. It's another type of quadrilateral that's a parallelogram. And one of the special features of a rhombus is that all four sides are congruent. And then I missed the first one. All properties of the parallelogram hold true. And then all four sides are congruent, which means that we're going to have to find the length by using the Pythagorean theorem. And then also, diagonals are perpendicular. We have slopes that are opposite reciprocals. And again, it's the diagonals that I sometimes are having a hard time keeping track of. I'm still working on that, and maybe that's true for you as well. But as we look at this, a rhombus is a kite. Let's think about it. A kite has adjacent sides that are congruent. So if we go back and look at this picture, this side and this side, those are adjacent sides. Are they congruent? This side and this side. So for the video purposes, I did this side and this side. Are they congruent? Yes. And then I said this side and this side. Are they congruent? Yes. So we can say that a rhombus is a kite. That's true. But can we say a rhombus is a rectangle? And the thing is, this one is false. It could be a rectangle, but the feature that there's nothing specific about is that a rectangle has 4 right angles, and a rhombus doesn't necessarily have 4 right angles. But when we're looking at a rhombus, to show that something's a rhombus, just like a rectangle, the first thing that we have to do is we have to show that it's a parallelogram first. So these problems get more and more in depth when we look at these, because with the start here, we're given quadrilateral ABCD has vertices at 0, 6, 4, -1, -4, 0, and -8, 7. It says determine if ABCD is a parallelogram by showing that opposite sides are parallel. Show all work and explain our answer. So when we start here, we'll graph these points. 0, 6, and 4, -1. Let me label here A, B, C is -4, 0, and C is -8, 7. So here's C and here's D. And hopefully your picture's a little bit better than mine. And now that we've got the picture, again, what we want to show is that opposite sides are parallel. So when we're talking about parallel, we're talking about slopes, we're talking about rise over run. So when we draw our picture here, we're going to look at the slope of DC. And when we rise here, and I'm going to have trouble because my picture's a little bit weak, but here, -8, 7. So 1, 2, 3, 4, 5, 6, 7. So we went down 7. And then we went to the right. 1, 2, 3, 4. -7 over 4. We're showing that opposite sides are parallel. So we're going to show that AB also has a slope of -7/4. That's the opposite side. So we'll draw our triangle here, and this one is here. And when we count 1, 2, 3, 4, 5, 6, 7 up, but then we're going to go 1, 2, 3, 4 left. And even though we have a negative on top in the first one and a negative in the bottom on the second one, those have equal slopes, which is what we want. They are parallel because they have equal slopes. Then we look at the other two sides, which is going to be here. And again, hopefully your picture is better than mine, but our rise is 1. And then we're going to, wait, but we actually went down 1, and let me label as well, slope of CB. We went down 1, and we're going to go right. 1, 2, 3, 4, 5, 6, 7, 8. So down 1 and to the right 8. And our other side here, the slope, I'll pull this up so you can see it in a minute. The slope, we're going to go up 1, and hopefully that's 8. So we went up 1, we're going to go left. 1, 2, 3, 4, 5, 6, 7, 8. So up 1, A, B, up 1, left 8. Again, negatives are in different places, but they still represent slope of CB, negative 1, 8, slope of AD, 1 over negative 8. They mean the same thing. A single negative means negative. And now what it says is, it says, explain your answer. So if you don't have enough space right here, I put it right here on my paper, which is right in here for the people watching the video, where there's a little bit of space, or above the graph where there's a little bit of space on there, to just because I ran out of space. But if we look at this, what we know is that slopes of opposite sides are the same. So they are parallel. So opposite sides, to be more specific, opposite sides are parallel. And ABCD is a parallelogram. So now, if we look at part B, it says determine if ABCD is a rhombus by showing that the diagonals are perpendicular. So now we're looking at diagonals perpendicular. So let's look at, and I didn't label here, but let's label first. So here's A, here's B, here's C, and here's D. I'll start with looking at DB. So we want the slope of DB. When we're showing that something's perpendicular, we're looking at opposite reciprocals. So there's our length of DB, and then we'll draw in our triangle here. And again, hopefully your triangle is better than mine. So we went down 1, 2, 3, 4, 5, 6, 7, 8. We went down 8. And then we went to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And remember, we're better off simplifying these, and if you need to, type it into your calculator, type it into decimals. The negative 8/12 divided by 4 is negative 2, divided by 4 is 3. And then when we look at our other diagonal, so it's going to be the slope of CA is again, we'll make our triangle, and I can suggest that you use colored pencils to keep track of things, because this picture is pretty drawn up now. But when we look at this, the slope went down 1, 2, 3, 4, 5, 6, down 6, and then we went to the left 1, 2, 3, 4. And when we simplify that fraction, again, use Desmos, use your graphing calculator if you need to, we get, I need a -4 because we went left 4. Negative divided by negative is positive, and when we divide, we get 3 halves. And what we see here is that these are opposite reciprocals. We flip the fraction, one of them's negative, one of them's positive, so it says, show all work and explain your answer. See if I can write it a little bit shorter this time. A, B, C, D is a rhombus because the slopes of the diagonals are opposite reciprocals, which means that they're perpendicular. Example 2. Quadrilateral EFGH has vertices at those 4 points, and we'll graph those. And what we've got is we've got 1, 8, which is E, 6, -1, here's F, -4, -4, which is G, and -9, 5, which is H. Again, I hope that your picture is better than mine. It says determine that EFGH is a parallelogram by showing that diagonals bisect each other. And when we're doing that, when we have to show that they're bisecting each other, what we have to do is we need to do the midpoint. So once again, in terms of the diagonals, we're going to do the midpoint of, let's do HF first, it doesn't make any difference. But the midpoint of HF, what we're going to do is we're going to draw a triangle again. And what we did is we went up. 1, 2, 3, 4, 5, 6. We went up 6. And we went left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So when we're looking at the midpoint, we're going to cut that in half. So we're really going to go up 3. And we're going to go left 7.5. So our midpoint up 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7.5. And I want to look one more time. One, 2, 3, 4, 5, 6, 7.5. So our midpoint of this one, and I'm a little bit off on my picture, but it looks like it is negative 1.5 and then 2. We also have to do the midpoint of GE. When we look at the midpoint of GE, once again, we'll draw our picture. And what we did, and I should have gone the other direction here, but since I did, I went right. 1, 2, 3, 4, 5. We went right 5. And then we went up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 12. But we're dealing with the midpoint. And the midpoint means that we're going to take half of that value. So it's going to be right 2.5. It's going to be up 6. Half of 5. Half of 12. So right 1, 2.5. And then 1, 2, 3, 4, 5, 6. And again, what we see is that our midpoint is negative 1.52. And then once again, try to keep it short. But slopes, the diagonals bisect each other. I'm going to have the same midpoint. So they bisect each other. And EFGH is a parallelogram. So part B. Now that we've shown that we have a parallelogram, we want to determine if EFGH is a rhombus. And what we need to show for it to be a rhombus is that all 4 sides are congruent. So we have to do the distance here. And here comes some more triangles to work with. But when we start, and I'll go back and label, but we have not the right picture because I missed the 1/8, so I'm going to have to draw again. Once again, I redrew the picture, and now what we're going to do is we want to show that all 4 sides are congruent, and at least I can make this a little bit shorter after we find the distance of GH. Because the nice thing is, if it is a rhombus, then we're going to have the same calculation for all 4 sides. We might have the numbers out of order, but we're going to have the same 4 calculations. But we're going to start by drawing our triangle. And what we see here is that we've got 1, 2, 3, 4, 5. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we do the Pythagorean theorem here, it's 5 squared plus 9 squared equals c squared. And we've got 25 plus 81 equals c squared. If we add those together, we get 106 c squared. And we can take the square root of both sides, and we end up with c equals the square root of 106. Now again, the thing is now, for the rest of these, it should work out. Keep my fingers crossed. If it is a rhombus, we're going to have the same calculation. So if we do the distance of HT, looking at our triangle, we've got 1, 2, 3. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. When we recount it, we get 10. And as we look at this, we see that they're not the same numbers. We get 9 plus 100 equals c squared, which is 109 equals c squared. And when we take the square root of both sides, we get c equals the square root of 109. And if there's any nice thing here about this one, is we don't need to do any more calculations, because what we see is that this figure, E, F, G, H, is not a rhombus, because the side lengths are not congruent. So finally, to get into a little bit of algebra, each quadrilateral below is a rhombus. Find the value of the missing angle. Now the thing about it with the rhombus is that a rhombus has 4 congruent sides. So as we mark this one up, what we see, if we're looking at a particular spot here, is we're looking at this triangle. We want to figure out what is the length of ABC, but it's an isosceles triangle that we're looking at, which means that angle C here is 35, but angle A is also 35. And if we remember, triangles have 180 degrees in them. So 35 plus 35 is 70. And when we want to figure out how big angle B is, we're going to take 180 minus 70 is 110. And that's angle A, B, C. Letter B. Figuring out angle VUS. Again, these are rhombuses. And the thing about rhombuses are that diagonals are perpendicular, which means that this value right there is a right angle. So consequently, what we know is we know the 28 degrees plus our right angle, which gives us 118. And we want to figure out VUS. We want to figure out that angle right there. So what we're going to do is we're going to take 180 and subtract 118. And 10 minus 8 is 2, and 7 minus 1 is 6. So our angle VUS is 62 degrees. Quadrilateral ABCD is a rhombus. We want to find the value of x. Well, once again, with regard to rhombus is that this length and this length and this length and this length are all the same. And because they have 4 congruent sides, we can say that x plus 9, that side length, is the same as 5x minus 87. Solve it the way your Algebra 1 teacher taught you. I'm going to move my letter to the left. I'm going to subtract 5x from both sides. And we get negative 4x plus 9 equals negative 87. Add 9, subtract 9 to both sides. And we get negative 4x equals negative 96. And then finally, we can divide both sides by negative 4. And we get x equals 24. Find the value of x. And lastly, again, still working with a rhombus. This one's a little bit hard to see. But we've got negative 14 plus 4x. And we've got the 54. And we've got diagonals bisecting each other. And what we can see here, another thing that's a hint, is that there's one tick mark here, and there's one tick mark there, and we get negative 14 plus 4x equals 54. And when we solve, we can add 14 to both sides, so we get 4x equals 68, and divide both sides by 4. The x goes in there once, I think 17.